All right, John, you're on.
Good evening. Good evening. Welcome to the October meeting of the Baton Rouge Astronomical Society. This evening, our speaker will be Amy Northrop. She's talking about the Psyche mission, which is about to blast off, if I remember right, isn't it?
I covered that in the presentation.
Okay. So without any further ado, I'm going to hand the program over to Amy now. Amy?
All right.
All right. Can we get the lights dimmed over here, please?
All right.
I'm a solar system ambassador, which is through JPL's Caltech publication office, and kids always think it's so cool that it actually says on the back of my ID badge, if found, returned to the Jet Propulsion Laboratory. That tickles them to no end.
Yeah, that's pretty cool.
Yeah, I've had more than one call me a rocket scientist. Sadly, that part is not true.
Okay.
So my opinions do not represent any of the partners of this facility, and my opinions do not reflect upon NASA or JPL either. Okay, now that we have the legal stuff out of the way, let's have some fun. So the target is 16 Psyche. This number 16 represents that it is the 16th asteroid that was discovered. All asteroids have a number that identifies the order in which they're discovered, and they will have that number even if they don't have a name assigned to them yet. This one was named after the mortal woman later who became a goddess that fell in love with the god of love, Eros. It was discovered in March of 1852, and it is the most massive M-type asteroid. For comparison, in terms of where this asteroid's discovery date rates, Ceres, the largest asteroid, which was the first one discovered, was discovered on January 1st, 1801. And they kept thinking they were finding new planets, and then about 25 down the line, they're like, okay, these can't all be planets, and they put them in a little category called asteroid, which means star-like, because they look like just a little pinpoint of moving light in most telescopes. Now, what do I mean by M-type asteroid? Most asteroids come in three types.
I had to switch back for.
Okay.
Okay.
Can I click now?
Is this what you call a pregnant silence?
Say next time.
I think we're having some technical.
There you go.
There you go, try it again.
Okay. The most common is C-type, which stands for carbonaceous. These are called chondrites, and they tend to be the dimmest and hardest to see because of their high carbon content. But they are the most numerous in the asteroid belt. S-type is called stony. They're very high in silica. And M-types are very high in metal, usually iron nickel. Psyche actually made a lot of attention in the news a few years ago because when the mission was announced, they're like, oh, NASA's sending a mission to an asteroid worth over $1 quadrillion in metals.
Yeah.
Well,
Yeah, sure.
I don't know about that, but we're going to. They actually recently think that the estimate was greatly overestimated. But we won't know for sure until we send a little surveyor there, which Psyche will do that for us. So what does Psyche look like? Okay, that's not very helpful. This is about the best photo or seriously photo we have. I actually spent multiple hours trying to find a good image, and this seems to be the best image they have. They have radar maps, but they don't actually have a real photographic image. These were actually taken by the Harissa survey. And you can actually see many divots in the asteroid. It's not actually perfectly ovoid. It appears to have chunks missing, which is of interest to scientists because they don't really know what caused these. Which is why part of why Psyche is such an interesting target. There's actually three main theories as to how Psyche may have formed. Theory one is Psyche the remains of a protoplanet. A protoplanet is a baby planet, for lack of a better term. They actually think our moon was formed when another protoplanet called Theia, after the mythological mother of the moon, actually struck Earth a glancing blow and created a ring that formed our moon. Protoplanets were a lot more common in the early solar system before they collided and merged and made the 8 major planets that we know today. So the question is Psyche the core, the remnant of a protoplanet? Did something happen to it? We're not sure. Any questions about theory one or anything else I've covered so far?
Is it because they think it's what you said, iron nickel?
Yes. As far as we know, Psyche is almost entirely made of metal, based on the surveys we've seen. So that's why they're wondering is if the core of a protoplanet and the rest of the protoplanet just gone through impacts. We're not really sure. That's one of the awesome things about science. Theory two. Oh, any other questions? Okay. Theory two was Psyche disrupted and later reformed into its current form. The early solar system was a very, very violent place. You don't have to look any further than Mars or the asteroid belt to see that, because they actually think Mars was supposed to be a super Earth in our earliest computer simulations. We now know that Jupiter stole a lot of its lunch, because apparently Jupiter moved in its early history. So that could have caused such disruption in Psyche. Another thing is it could be like here is our Psyche image again, but it could be like Uranus's moon Miranda, which one of its theories is that this portion here, which has the weird topography, and you can see it appears to have less altitude and be lower than the rest of the moon. They think something broke Miranda apart and it turned, and we're actually seeing the underside of the original moon there. That's one of the theories that they gave for Miranda, but unfortunately we're not sure because the only mission that was ever sent there took photos at a high speed and then flew on to Neptune. The image in the background of my theory slides is actually an artist's concept because we don't have very many good photos of Psyche, but they have a good idea of what they think it may look like. And there's very deep impressions here, which brings me to theory 3. Has Psyche experienced ferrovolcanism? Say what? It has never been observed before in nature. Volcanism is very present in the solar system. You have standard volcanism both on Earth and Io, and you have cryovolcanism on Enceladus, and they think even on Neptune's moon Triton. But they actually think that there are 2 types. The Syracuse Lava Project has actually been doing experiments as to this because they try and figure out how lava would form or react on other planets. To test how lava might behave on Io, they'll actually pour lava onto frozen surfaces to see how it will form. There are 2 types. Type 1 would occur on entirely metallic bodies, and we don't have any quite idea how this would behave, because if there is ferrovolcanism on Psyche, or was at one time, it will be the first we've ever observed. Type 2, on the other hand, was observed and produced by the Syracuse Lava project. Basically, the way this happens is here's some of their normal lava. This here is iron that actually sunk to the bottom of this mass of molten material, and then it came out and caused a little offshoot that moved and flowed very quickly. Soldati, who actually wrote the article about this, says that the cones produced by ferrovolcanism would have gently sloping broad cones similar to what you would find in Hawaii. The volcanoes, if there are such a thing on Psyche, would not resemble the typical stratovolcanoes like Mount Fuji or Mount Rainier. Okay. Any questions about theories? Yes.
What's the diameter of Psyche?
It's one of the big ones, but if you were to put it next to Ceres, you'd probably hardly notice it, because Ceres contains most of the mass of the asteroid belt just by itself.
Maybe would it have, were they thinking for ferrovolcanism that it would have an internal heat source, or was it from like tidal forces?
They are unsure at this point, because right now they're just like, which of these is most likely? We don't know. We have horrible pictures. We want to send a spacecraft to take a better look. Typical case of scientists going, we don't know stuff. Let's go take a closer look. Which, yay. Yes?
It's 140 miles in diameter.
Okay, 140 miles.
I know Ceres is like 600.
For comparison, Ceres is as great is as large as Great Britain. Okay. Now, the original launch timeline, it was supposed to launch in August of last year. Then it was supposed to get a gravity assist from Mars in this year and reach Psyche in 2026. Okay, what happened there? The Guidance Navigation Control System, or GNC computer, was delivered a month before launch was scheduled, which left them with inadequate time for testing, and it was decided by a review board to just delay the launch, which will lead to some very interesting navigation calculations that I will get to in a little bit. Okay, so I've gone on about the target and the basis of the mission. Why don't we look at the actual spacecraft itself now? Oops, got a little ahead of myself there. Let's look at the goals. First, they want to understand a unexplored building block, iron cores. We know iron cores are important to planetary formation. Geologists and seismologists have been trying to study ours on Earth for over 100 years with varying degrees of success, but it's kind of hard to study something when you can't get to it because the heat and pressure will kill your little instruments. The closest we're able to get with ours is just listen to earthquakes and see how the sound moves. So we want to look inside terrestrial planets by examining the interior of a differentiated body. A differentiated body is like Mercury, Venus, Earth, and Mars. They have nice layers because as they formed, the heaviest material sunk to the middle. And then they formed layers, and their geological processes allowed plate tectonics to develop on Earth. And probably maybe on Mars. We're still not sure, though. We know Mars has had Marsquakes. It still feels weird to say Marsquake. It's not an earthquake, it's a Marsquake, but it still feels weird to say. And explore a new type of world, one completely made of metal. Because we've explored rocky ones with Mars, and we've explored ice with the orbiters we've sent to Jupiter and Saturn, and looking at all of those icy moons. But Psyche is going to be something completely new. Which brings me to the science objectives. They want to determine if Psyche is a core or if it's just an unmelted hunk that broke off of another asteroid. They want to figure out how old the regions are. This will tell us whether or not there is volcanism, if some areas are younger than other areas. And they want to determine whether small metal bodies incorporate same light elements of Earth's high pressure core. And they want to determine whether or not it formed under similar conditions to Earth's core, whether the heat and pressure were similar. And finally, study its topography. What are those big depressions on the surface? Were those caused by volcanism, or did something smack it and knock a huge piece out of it? Okay. Any questions on the objectives before we move on to the spacecraft itself?
How in the world do they have any idea about the oxidizing versus reduction of both Earth's core and Psyche?
Those objectives were pulled directly from the Psyche website.
Okay.
So that is the exact wording of the objectives and goals they want to
Scientists
have.
know, but we don't.
Yeah, but activity of radio waves.
What was it?
The activity of radio waves.
The
I mean,
what wave?
Radio waves.
Radio.
Oh, okay. All right. Listening to it, what did you say?
That- He's not wrong in the fact that the only reason we know that our outer core is liquid is because there's areas where there's the seismic waves just behave weird, and they're like, this is like it's going through a cliff. We have a liquid core. And they actually were able to calculate the size of it based on where the shadow occurs and how the waves bounce. They are way better at math and differential physics than I am, because yeah, the idea of calculating all of that makes my head hurt. Okay, so the body of the spacecraft is fairly small. It's only 10 feet by 8 feet wide, and this right here is its radio antenna. Now, how is this little sucker going to get powered? Solar panels, which are 81 feet by 24 feet in size. You have humans here for scale. At Earth, it will produce 200 kilowatts of power. At Psyche, the power will be reduced to only 2 kilowatts. That is a little more than is used by a hairdryer. Solar panels. You don't have to carry any fuel or reactant mass, but you kind of get diminishing returns as you go further and further out. But it is more than enough to run Psyche's instruments because they have carefully optimized these instruments in order to handle the reduced load. Okay. And as you may have seen on the first slide, Psyche is actually behind this panel. There are 2 other panels that will fold down and up to make cross shapes on each side. When its solar panels are fully deployed, the spacecraft will be approximately the size of a singles tennis court. Okay, now how is it going to move itself around? Ion engines. Ion engines are interesting because they've actually been theorized since Star Trek. There's actually an episode where they actually make a comparison to the fact that, oh, these are hundreds of years ahead of us. Well, we have ion engines. We, however, do not have a USS Enterprise. I feel cheated.
What gas are they using for it?
They are using xenon.
Xenon, okay.
The way an ion engine works is it throws out very, very small amounts of atoms. It actually has a very weak thrust, but it can thrust continuously over a very, very long time, which builds up to a significant velocity over time. Dawn actually kind of set the record for having the longest engine burn time in spacecraft history because it just kind of left its engines on for a duration that wouldn't have made other spacecraft cry because it just left its engine on for over 6 months.
Wow.
Didn't really care. Okay, now for the instruments. These are the instruments that Psyche will be carrying, and I will go into each of them one by one. Does anyone have any questions at this time? Yes.
Do they have a, like, how long they expect it to, they always go past it, but do they have like a?
I will have in my presentation with a full projection of the mission timeline at this time. Though, as you pointed out, that is probably subject to change. The Jet Propulsion Laboratory builds these extremely well. Okay, first we have the multispectral imager. It will provide high resolution images using different filters to differentiate between the metal components and the silicate components of Psyche. The instrument actually has a pair of identical cameras which are designed to acquire geological, compositional, and topographical data. The second camera is actually a backup for the mission critical navigation system, which uses optical observation. The team for this instrument is based out of Arizona State University. This is the gamma ray and neutron spectrometer, and it will map the elemental composition. The instrument is mounted on a 6-foot boom to distance the sensors from the background radiation caused by the spacecraft. And this is operated by the Applied Physics Laboratory at Johns Hopkins University. Now, this next one name is kind of self-explanatory, but it's the magnometer. This is designed to detect the remnant magnetic field of the asteroid. It has 2 identical high-sensitivity magnetic field sensors that are also at the end of the 6-foot or 2-meter boom. This is to prevent the magnetic field given off by the spacecraft's instruments from causing interferences. A good example you can see of this is looking at the spacecraft Juno. Juno kind of took its I cannot speak today, I apologize. Magnetometer to an extreme because it sticks, it's all the way at the end of one of its solar panels. Okay. And this instrument is based out of the MIT and the Technical University of Denmark. It will be using its X-band radio telecommunication system to measure Psyche's gravity field with high precision, and when it's combined with the topography information, it will be used to help us determine what the interior structure is like. This instrument is going to be based out of MIT and the Jet Propulsion Laboratory. And this next one is kind of exciting. It's a communications test for a laser-based communication system. They're hoping that it will be able to encode data into photons rather than radio waves. And they're hoping this will allow it to communicate more data at a given amount of time. JPL is spearheading this. To give people a sense of why this is important, when the the New Horizons spacecraft did its flyby of Pluto, it actually took it over months to send us all of the data from that flyby because they opted to use a smaller antenna to save on space and launch weight, which meant it had a smaller bandwidth of data it could send back to us. So they had their fingers crossed nothing would happen to New Horizons until it got all of the data back. Thankfully, nothing went wrong, and New Horizons is still, to my knowledge, chugging away.
It just extended it for another 5 years mission.
Wow.
It was meant to just go to Pluto. It's visited Arakoth, and it's still going to go for another 5 years. And Voyagers are still going. Those spacecraft are over 40 years old.
The New Horizons, NASA wanted to repurpose it for other stuff, but Dr. Stern and his group who ran it did a campaign, and they got NASA to agree that yes, they're gonna keep it going to find more bodies out in the Kuiper Belt with a 5-year extension rather than being repurposed.
That sounds like Dr. Stern. He,
Oh, yeah.
he loves that little
Something
mission.
else.
Now, before I go into the new timeline, are there any questions about the instruments?
The communications, is that directly back to us or is there some kind of relay?
At this point, it's just a test. The maps I will show of its route actually have in little dotted lines the opportunities for them to use the instrument. So it seems like it's based on us or bouncing it off of something that isn't shown on the map. So I lean towards us.
Could be where they're gonna do just a good line of sight,
Yeah.
the laser. You know, it might not be a good line of sight, it might be angled too much. We probably wanna get a fairly good straight on shot for it to test it.
Now, for the new timeline, it will be hopefully launching on October 12th at 10:16 a.m. EDT from Launch Complex 69A. Its launch window is actually from 8:38 a.m. to 12:38 p.m. And its launch windows are rather small for a spacecraft of like this. It's only a 4-hour long launch window. And if it misses all of its October launch windows, they do have auxiliary launch windows next year. It will be launching with SpaceX via Falcon Heavy, and they're going to land the boosters at landing zones 1 and 2. Now, it will be launching here in October. And see these dotted lines? These are the little dotted lines where it will be able to use the deep space optical comm system. It will travel along this route until it passes by Mars. They still managed to get a Mars intercept, even though it's not very optimal with this. It's going to take them 3 years to get to Mars instead of just 1 year with the original timeline. Then it will continue moving further out into the solar system, finally arriving at Psyche in August of 2029. And here you can see these color-coded letters A, B1, D, C, and B2. These refer to orbits that it's going to have around Psyche. And here, this diagram shows the amount of surface lighting that the asteroid will have. And here are those orbits I mentioned. This is going to be orbit A, B1, C, D, and then it'll come back here for B2. And here it actually has the duration of each. Okay. Any questions?
Yeah. Have the rotational axis and rates been calculated?
I've seen them
Determined.
simulated, but none of the estimates I did, they didn't seem to have full confidence in the
Yeah.
actual speed.
I was just curious about, how much coverage they're gonna get on each orbit, depending upon its, which axis it's turning in, what rate.
Well, they seem fairly
Seems like they're gonna
confident.
catch a lot.
They seem fairly confident in this, and the end of mission there isn't going to be until November 2031. So they're going to be there a while.
Do they have a way to adjust when they get closer and they can define their orbit and all that a little more accurately? Do they have a way to adjust their spacecraft?
They do have the ion engines, and usually missions like these also have additional thrusters for more fine-tuned. I didn't see any specifically listed, but it is fairly standard to have fine control thrusters as well as a flywheel to help adjust your orientation without expending fuel. Okay, well, if there are no further questions, I want to end with,
We don't have one.
yes,
As far as the tasks are concerned, are most of those gonna be pre-programmed or will some of them be radioed?
I believe they're gonna be using a combination. They're probably gonna give it a set series of tasks. It's gonna report back and they're gonna give it its next series of tasks. It's gonna depend, each duration is probably gonna depend on where it is in its orbits. Yes?
I know you didn't cover it, but two things I wanted to ask. You didn't cover anything about how much it cost, and two, was the delay was only because of the what you call it, the Geiger?
Guidance system.
Guidance system, was that the only reason it was delayed?
There were some other reasons they gave for the delay, but that seemed to have been the main trigger that led to them deciding to go ahead and push it back, because they did not feel comfortable with the system when they only had a month to test it before it was supposed to launch.
And some of the dates don't be there, because if you're doing a flyby of Mars with gravity assist, it has to be in the right position for you to do it. So that's why, another reason why certain things got delayed, because they gotta wait until Mars to get in the right position to get the gravity assist when it gets there.
It was optimally positioned for them to have done the gravity assist during the August launch window. But with the delay, I was genuinely surprised when I double checked this and saw that they were still gonna be doing a Mars flyby. It's a far one, it's gonna be over 3,000 kilometers away from Mars, but they're still getting the gravity assist. But that's a credit to the flight engineers who calculate all of this stuff.
Yeah.
When I saw your face when I said something about the cost of it.
Yeah,
I'm thinking it's over.
If you have to ask, you can't afford it.
Yeah.
A trillion here, a trillion there adds up. after a while.
Counting inflation.
Those good old astronauts.
yes.
I think you said this, but when's it supposed to land on Psyche?
It is not landing, it is an orbiter only. It will be arriving at Psyche in 2026. 29, excuse me, 29. No, I got my dates crossed. It was supposed to arrive in 2026 before the delay. Sorry. Wishful thinking on my part. But no, physics says no to that timeline now.
Is there any other questions?
That's the plan.
Is it?
Well, keep me in mind if you'll need a slot full for next year.
Oh, I'm sure we will then. Okay, Scott, we done with the live streaming now or not?
Yeah, we can hang up on everybody, just,
Yeah.
go ahead and close the meeting, I'll show it all.
Okay, then, so that concludes our program for this evening. That's going to be concluding our live streaming. We're now going to go to some regular club business if we can. Okay, I do